Hello everyone, today in this video we will talk about loop in C programming. I'm instructor Milan Gemire. After watching this presentation, you will learn about all the loops in C programming. To get started with this presentation, you do not need any prior knowledge of C programming. It is completely beginner friendly, but it will be better to watch the statement part 1. The link will be given down in the description. To access the full playlist of the C programming, the link is also provided down in the description. If you are new to our YouTube channel, please do not forget to subscribe our YouTube channel. Let's get started with loops. Loops are control structure in C programming, which allow repeated execution of a block of a code as long as the condition is true. Loop reduce the redundancy in the code and perform the repetitive task efficiently. It is like revolving. You will get one condition. The condition will be either satisfied or it will be not satisfied. If it is satisfied, it will go to the next line of code. If it is not satisfied, then the same block of code will be repeatedly executed. It is like a washing machine that revolves until the cloth is become clean. There are different types of loops in C programming. Mainly while, do while, and for loop are the major type of loops. This table will be very clear for the representation of loops and the differentiation of the loops. It is very important table so that you will understand each and every loop better. Here, for loop, condition is checked before each iteration. In while loop, also before each iteration, but in do while loop, after each iteration. Initialization at the beginning, outside the loop and outside the loop. Use case, for loop, non-iteration, while loop, condition driven task, and do while loop execute at least once. This table will be more clear when we look each of them. So first we will look about for loop. What is for loop? It is a loop which is used to repeat a block of code until the satisfied condition is met. Here in the flowchart, we will first get the initialization expression. So this is an initialization expression. We will first encounter with the test expression. Anything, the condition that we have to test. If it is false, here you can see if it is false, it will directly go to the next part of the code. Here any other code or the procedure order. But if the condition is true, the for loop body will be executed. After that, update expression and again go to test expression. In this manner, the test expression is continually updated. If it is not updated, then this loop will be forever. So we should know that the expression should be updated very carefully. It is used when the number of iteration is known before we start the loop. For the syntax, you can see here for, we'll put the initialization, the condition, increment or decrement. So this is the syntax. First we will initialize one value. We'll put the condition over there and we will increment or decrement the initialization value or the conditions. Here you can see test expression, loop body and update expression. This increment or decrement will update the expression. The test expression is evaluated. First of all, here you can see this is the test expression. This is first evaluated. After that, if false, loop terminate. If it is false, the loop is terminated. If true, the loop body is executed. If true, then this body is executed. The update expression is executed after each iteration. So after each iteration, the expression is updated and again the loop is executed. So step 1 and 2 repeat until the test expression become false. So this will be repeat until the test is false. When the condition is false, then it will just leave the loop and continue its operation. When false, the loop terminates. So this is how for loop actually works. So now let's see the example. Okay, here in this example, this is the header file. Include stdio.h and int main is the entry point for any programs in C programming. Here we have initialized the I value as an integer. We have not assigned any value to this variable till now. Now here this is the for loop statement. It is started with for I equals to 1, I less than 11 plus plus I. It is a pre-increment. It doesn't matter until we assign with its value or with the variable. Here the increment is done like I equal to I plus 1. Here you can see this is the initialization part, this is the condition part, and this is the updating expression part. Here you can see the I is assigned with value 1. For loop is started, I value is 1 and I is less than 11 and I plus plus. Now this had defined us like I is ranging from 1 to less than 11. That means I is ranging from 1 2 less than 11, it means 10. Now here you can see inside the loop what is happening here is printf %di. Now we are printing the value of I, that is for now I is equals to 1. In first iteration, when it goes, the condition is not satisfied. That is, the condition over here is not outside the loop, it is inside the loop. Here you can see I value is 11, less than 11, yes. Then 1, the 1 is printed. Again what happened? The condition is checked. For loop wants to exit, but it is not exiting, not giving to exit. It is not satisfied. It want to get satisfied and move to the next line of codes below it, but it is not satisfied. Here I will be 2 in second iteration because I plus I will increase the value of I by 1. That means 2 is less than 11, and again now 2 is printed. Likewise, what we will get until 10. Now in the 10th iteration, here 10, I value will become 10, like 3 to 10. Now what happened here? After 10 is printed, the value will become 11. Now 11 is less than 11. No, it means it will leave this part. It will satisfy to leave the part. For loop want to go outside. The control want to go outside the loop, and it will just leave this for loop, and what we will get is like 1 to 10. This is how for loop works. Another example that will make you very clear include stdio.h. This is the header file, int main. This is a entry point. Here you can see the sum is initialized as 0. Sum is equals to 0. For here, the for loop statement is used. Here what we are doing is for int I equals to 1. Here we can define the integer I itself in this part. Int I is equals to 1. That is, I value is for the first iteration, that is 1. After that, I is less than or equal to 10. Now you got it. I is less than or equal to 10. That means it can range from 1 to 10 because here is equal to, so it should not be like 9 less than or equal to 10. That is I means 1 to 10. And what we are doing is in each iteration I plus plus. And what we are doing here in the statement part or the loop body part, sum plus equal to I. What does it mean? That is like sum, sum equal to sum plus 1 or sum plus I. Sum equals to sum plus I. Sum is initialized as 0. For the first iteration, 0 is equals to 0 plus I value is 1. You see this? Then what happened is this variable is holding 0 plus 1, that is 1. Now sum value became sum equal to 1, right? And the second iteration start to work. The I had already increased. Now I value is 2 and the sum value is 1. You got it. And here I equals to 2. I is less than or equal to 10. Yes, it is less than or equal to 10 and I plus plus. Now what happened? I value is 2. Sum value is 1. Now sum is equals to sum plus I. Now that means sum is now what? That is already 1 and I is 2. Now 1 plus 2, sum became now 3. I also increased by 1, that is I equal to 3. Again in the same manner, it will start to get the sum of I, that is from 1 to 10. Now what happened here? 1 plus 2 plus 3 plus 4 plus 5 and likewise up to 10. The first 10 natural numbers sum is over this variable, that is inside the sum. Now what we are doing is we are printing %d sum outside the loop. You should understand that when it reaches to 10, it is equal to 10 will also iterate, but when it reaches to 11, that is I equal to 11, in this case what happened? The loop will exit and the control will come over here. The sum will hold the value of all the sum like we did before. Now the answer became 55. So in this way, we can use the for loop to add repeatedly as well. Now let's dive to while loop. It is entry verified loop. It allows a part of code to be executed multiple times depending upon a given Boolean condition. The Boolean condition, either it is true or false. Here in this flowchart, you can see while loop, it is started. At the very first, the condition is checked. If it is false, it will directly end. If it is true, execute the loop body and again do the same. Previously we have looped one table. In the table, before each iteration outside the loop, condition is driven task that we have understand. Condition check is before the iteration. Before the iteration is started, the condition is checked and it is initialization is done outside the loop, and condition driven task, that is according to the condition the task is performed. Mostly used in a case when the number of iteration is not known in advance. Previously in the for loop, we know the range of the loop, that is like we are ranging from 1 to 11, right, 1 to 10. But in the while condition, we are not known to the iteration. We will only check the condition and do our tasks. So it is a condition driven task. You will be more clear in the example. Here you should know the syntax: while, the condition, and the code to be executed. It is very simple. If you don't know the range of iteration that you want to print or you want to execute on, first of all it will evaluate the condition. As I have said, if false, skip the loop. If true, execute the loop body. Repeat step 1 until the condition become false. If the condition become false, it will just leave the loop. So it is quite simple. By this example, you will be more clear about while loop. Now, I will just directly make you clear over this part only. That is, I is less than or equal to 5. You should put attention to this part. Until now, this is the header file. This is the int main is the entry point. I equal to 1, we have initialized I as 1. So first, for the first iteration, I is equals to 1. And printf %di, as you should know, again, that is, we are printing the I value, just this I value as %d plus I, we are increasing the expression. Now here you should know that for the first time it is only checking the condition, and at the end we are increasing the value, updating the expression. Why we are doing this is like we don't know how much is our range or how much the iteration should occur. That is, I is less than or equal to 5. That means it may from minus 18 to 5 or 0 to 5 or 1 to 5. We don't know about it. According to the user input or the initialized value, we have to perform this loop. In this condition, while loop is very useful. Like I is less than or equal to 5. Now this is the condition. I equals to 1, that is the value is 1. 1 is less than or equal to 5. Then it is giving the boolean expression yes or no. If 1 is less than or equal to 5, yes, we are getting yes, that is true value, true boolean. So when the true boolean occur, the printf %d I will be occurred, and if it is false, it will exit the loop. Now what happened over here? I think you can guess it. Yes, of course, we will print 1 to 5. That's great. Now let us go to another example that will also make you very clear in this loop. Here you can see we have previously done this example in a for loop, but here we are using while loop. Again, we have initialized the I value as 1, sum as 0. Why we are initializing sum equal to 0? In the previous program also it may be confusion, right? The sum is equals to 0 because while doing the program, the sum may be holding the garbage value. So garbage value means like a random value like 2, 4, 8, 6, right? So any random numbers. In order to handle that condition, we are initializing it with 0 so that no error occurs, right? So while operation, while loop is used over here. I is less than or equal to 10. Now what happened? I is 10. We have initialized I as 1 already. Now this can be taken from user as well, right? Like enter the number, how much number you want to start with, then scanf, we are taking this I value, but we have initialized it with 1. 1 is less than or equal to 10. Yes, the true boolean is occurred, and sum plus equal to I. As before, sum equal to sum plus 1, and what happened? That is 0 plus initially 1, that is 1. And what we are doing? We are storing over sum is itself in the sum, that is sum is equals to now 1. Another conditions occur here, I plus plus, that is I plus 1, that is 2. Now 2 is less than or 10. Yeah, of course, it will add 2 until 10. right? So I will add this number for you. So here you can see, if we add this number, then we will get 55. So the answer is again 55. How easy is this? So while loop is one of the very handy tool while we are doing a big project as well. So I think you understand, first of all, what we are doing. While I is less than or equal to 10, that is until the I value is less than 10, we are doing this iteration, this bunch of code we have performed. If it is exceeding 10 value, then we are going out of the loop and printing this number. So this is quite simple. So the output is like 55, you can see over here, and this is how while loop occurs. Now do while loop. Do while is an exit verified loop. While loop was entry verified, now this is exit verified. The test condition is checked after executing the loop body. Here you can see in the flowchart, the code block will first execute once, and after that only it will check the condition. If the condition becomes true, it will again execute that block, else it will terminate the loop. So until the condition is satisfied, it will continue to loop, but when the condition failed, it will go. So the previous table also clearly mentioned that after each iteration, the condition is checked, right? The condition is checked after each iteration. So use case is execute at least once. Once the code will be executed, either the condition is satisfied or not, the block statement should execute once. So one iteration will be default. Here you can see, first of all, the syntax looks like this: do while condition. The code to execute will be here. So do code to execute while and condition. Execute the block inside the curly brackets after do. Evaluate the condition in the while statement here. If it is true, go back to state number 1, that is executing this code, and if it is false, exit. So either the condition is satisfied or not, it will execute once, that is for sure. Now let's see the example so that it will be more clear for you. Here you can see include stdio.h header file, the entry point I is initialized as 1. Now here you can see the do statement. This is a do while loop. Here do printf %d I plus while I is less than or equal to 5. Now here you can see we are printing the value of I. Either the condition is fulfilled or not. This condition is checked at the very last of the code or statement after completing the loop body. So we are printing I for the first time in the first go. Here I have initialized the I as 1, that is 1 over here, and this is printed. So 1 is already printed. I value is 1 in the first iteration, it is printed already. And while I is less than or equal to 5, now what is it's checking? The I value is increased and the I is checked less than or equal to 5. That is, now I in the first iteration before printed, right? Or at this part, in this point, I value is 1. After this, I value became 2, right? Yeah. Now here, I is less than or equal to 5. That is, 2 is equal to or less than 5. Yes. Then again it will go. It will print. Now 2 will print it. After that, it became 3. It became 3 here. I value became 3. I is equals to 3 now. Now the condition is checked. I is less than or equal to 5. That is 3 is less than or equal to 5. Yes. Then what happened? It will go over here and %di, that is 3. 3 is printed. Again what happened is I plus this 3 will be increased and became 4. Now again it is checked less than or equal to 5. That is 4 is less than or equal to 5. Yes. Then what happened? It will go to print again. So 4 is printed and I that is I is equals to 5. Now here equal to 5. Yes. Again go to print. Again we are printing this. And now here it becomes 6. Now I value became 6. Now while I is less than or equal to 6, I mean 5. That is 6 is less than or equal to 5. No. In this condition, this will be exit and come to this part. So 1, 2, 3, 4, 5 will be printed. So for the first time this will be printed, and after that only the condition is checked. In this way 1, 2, 3, 4, 5 is printed. So in order to make it more clear, this example over here, will be very best for do while loop. This is the small project that you should try on your own by pausing this video and learn by yourself. Well done. This is the entry point of the program. Number, sum. These are the variable. Number as an integer, sum as an integer holding the 0 value. As same as for the garbage error. We have initialized this with 0. Now, here you can see do. Printf, enter a positive number or 0 to stop. Now, do not focus over here, right? First of all, focus over here. Enter the positive number. We are asking the positive number. Scanf, %d and number. So what we are doing is, in place of number, we are asking a positive number, right? Or 0 to stop. Now come here. If the 0 is enter, we should stop. So we are just saying this. This is not the program. This is just for printing to make the user known that if you enter 0, we will stop. So we are writing the logic now. What we are doing, we are asking a positive number. We expect a positive number from the user, like 1, 2, 10, any positive number. Now sum is as initialized as 0. Sum plus equal to number. Sum plus equal to number. What does this mean? This means sum will hold the value of sum plus number, right? So this is like x is equals to x plus y. So x plus y will hold the value in x. So what is happening here? That is sum plus equal to number. Sum is 0, okay, 0, no problem, plus number. Here number, the number entered from the user, right? We are asking from the user. Let us suppose if the user input is 5, then what happened? 5 is added. Now this sum will hold the value of sum 0 plus 5. That is sum plus 5, 0 plus 5 is equals to sum is equals to 5 until this, right? So now what we are doing, while number is greater than or greater than 0. Now what we are doing, we are creating a condition that number is greater than 0. That is positive number. If the number became 0 or negative, I will not say over this, okay, you will try. What happen if negative number? Will it continue to ask to the user or it will stop? Okay, while number is greater than 0, until the number is greater than 0, that is the user input is greater than 0, we will do this block of statement or do this code. If not, if the user entered 0, then what happened? The loop will be exited and printf the total sum is %d plus sum, right? So if the user input 5, will it be printed as 5 or it will ask another number? Here we are entering the 5, then according to our logic it should ask another number because we are in the do while loop. Initially this is performed, we will get the 5, right? 5, if the user input is 5, it will again ask the number, positive number. That is, if we enter 10, that will add, that is number, sum is already 5 plus 10, that is 15, right? Again it will ask. If we enter now 0, then the logic become false, and what happened, it will just terminate and 15 is printed, right? So you should try in order to see the actual flow. Here you can see in the output that I have tried, that is 12. I have entered 12, 3, 5, and finally I entered 0 and I get the answer as 32, right? So you may ask, if we enter initially 0 for the first time, the 0 will be printed. As you said, for the first time it will work, right? In the first go, the block of code will execute. So it will ask the number, we enter the 0, the total sum is 0, and it will exit. So in this way, the do while loop works. This is all about loops in C programming. This is the basic idea that I have provided to you about the loops. So if you have any confusion, please do comment down, or you can directly contact me through my Instagram or through any platform that I have provided in the channel's description. Thank you so much for watching. Don't forget to subscribe.